Quad students, today is our asynchronous day. For you all, it is November 12th, Thursday. It is the end of the week for you, which is awesome. I hope you enjoy a long weekend. Hope you get some rest and gets caught up on some work as well. And then just find some time to relax. This video will give you some instructions. It'll be kind of like the start to our class. Tell you what we're doing today, and then at the very end, or I guess maybe even the second half, I have some bonus review problems. So if you want to go through any topic that we've studied, if you want to just see some more examples before our test next week, you can certainly do that. The daily problem is more of a joke than a daily problem, or like a riddle. It's actually more of a joke. A windmill asks his friend, "What's your favorite kind of music?" His friend turns to him and says, "I'm a big metal fan." Okay, never mind. Today, trivia question is, what year was Netflix started? So for each of these questions today, so when we actually get to math here in a sec, you can pause and then answer for yourself, try the problem for yourself, and then hit resume. So pause for a second, answer the question, and what year was Netflix started? I got 4 options there. And then when you hit resume, the answer will be on the other side of that. Netflix was started in 1997. Option A there, 1997, which seems pretty early, but good for them. Good for Netflix, you know? Today's video is brought to you by Flamin' Hot Cheetos. No, they don't actually sponsor me, but maybe one day they'll watch this and they'll send me some free Flamin' Hot Cheetos or something. I don't know. It's worth a shot, right? Today is what we call a stop day. What we're going to do, and I'll have directions here on the next slide. Please remember, this is not Monday, but next Tuesday, we'll have our Chapter 3 summative. And then Friday, I have the wrong schedule here. Friday, we are starting Unit 4. We'll intro Unit 4 here. So Tuesday, the next time I see you all in class, we'll have a summative. Feel free to reach out to me today at any time on Schoology. I will be by my computer pretty much all day today. If I'm in meetings, I'll get back to you as soon as I can. But feel free to reach out with any questions or anything that I can help with. So today is going to be a stop day, as you can see here. And really what that means is we are just taking a pause and catching our breath. I want you to stop today, look at your grades, see what missing work you have, maybe look back on older assignments that either went well and you're like, yay, I'm doing well, or B, did not go so well, and you can get some feedback on those. Remember, all of the paper or PDF assignments are hand graded, so you can see my notes on there. And so really your job today is to get caught up on missing work. I have quite a few people with a lot of missing work. And so today is your day, especially with no school tomorrow, to get caught up on some of that. So on the next slide, I have a list of all of the assignments. And if you want, you can take a screenshot and then just kind of check them off one by one, and make sure that you have them done and turned in. If you turn any of the older ones in, feel free to send me a Schoology message about that too, and just say, hey, Mr. Roach, I turned in lesson 1 homework or something like that. So today's your stop day. Here are our assignments so far. Lesson 1, we talked about just function notation. So this is like plugging into equations. Lesson 2, we had some homework on functions and tables and graph. So using function notation within tables and with graphs. And I have some examples here coming up. Lesson 3 was a kind of like an individual work day where you had some time to work through ladders. And remember, on this function practice, you need to do 2 problems per topic. So you don't need to do the whole thing. You just need to do 2 problems per topic. If you did the whole thing, that's fine. Not a huge deal. But it is 2 problems per topic. Lesson 3 also had a homework quiz. It was like a 5-question homework quiz with some diamond problems and some solve for X. Our most recent due homework was domain and range. This was due earlier this week. And then homework that you have due next week is our review worksheet. So here's a list of all of the material in Chapter 5, or Chapter 3, holy moly. Lesson 5 is what I was thinking. in chapter 3. I'm going to erase all my markings on there. Like I said, feel free to take a screenshot and kind of go use it as a checklist to go through those. So at this point, you kind of have two options here. You can start working on this assignment list and just making sure you have all of the Unit 3 stuff in. Or you can keep following along with this video and run through some review problems as well. So I've one of each topic picked out. So probably take like, I don't know, about 5 minutes, 6 minutes. Maybe you can time me. You can rewind, you can fast forward, you can just pick out the problems that you want to go through. It probably will be helpful for the test, but kind of optional on how you want to structure your day today. Or maybe you want to just come back to this video later and watch the review. These are questions that are just unique to this PowerPoint, so download the notes if you want to follow along or write them down on a scratch piece of paper. But the first one is function notation in just straight up equations. So plugging into these equations and the types of problems you might see. So if we have two equations, we have f of x and we have g of x, and we are asked to find g of 7. Notice that g of x turned into a 7, the x turned into a 7. So wherever I see an x in this equation, I'm going to replace it with a 7. One more time, wherever I have an x here and here, I'm going to throw in a 7 instead. So g of 7 would be 7 squared, which is 49, plus 7. So g of 7 would be equal to 56. I'm just plugging in there, and this one I'm following PEMDAS, my order of operations, in a normal order, so exponents before addition. A separate type of problem you might see looks like this, where it says find x when f of x is equal to negative 25. So this time I'm going to be using my f equation, where last time I was using g. And notice how the x is still there. I need to find out what x is, so I'm going to plug the 25 in for the y spot, or the f of x. So one thing that we talked about early on in this unit is that y is being replaced by f of x, and they really mean the same thing. So where I see an f of x in that equation, I'm going to put negative 25, and my equation is going to look like this. In the red example above, I followed PEMDAS in a normal order. In this blue equation, I'm going to undo stuff to solve for x. So if I want x alone, the first thing I'm going to do is subtract off 5 from both sides. And I would have negative 30 is equal to negative 3x. Negative 25 minus 5 more would be negative 30. And then I'm going to divide by negative 3, and I would get x is positive 10. So if I input 10 to this equation, I would get out negative 25. Kind of the last type of problem that you might see is one that combines both f and g. In this case, we have to find out what f of 0 is and what g of 1 is separately, and then we're going to add them together this time, it looks like. You could also see multiplying or dividing, but this one's adding. F of 0 would be negative 3 times 0 plus 1, using this equation up here, which would be 0 plus 1. So f of 0 is, oh, I'm sorry, it's 5. Let me back up. Sorry about that. This is 5 up here, plus 5. So 0 plus 5. So f of 0 is 5. Good thing I caught that. G of 1, so there's where my 1 is coming from. G of 1 using that other equation would be 1 squared plus 1. So 1 squared is 1, and then 1 plus 1 is 2. So if I take f of 0 and I add on g of 1, that would be this 5 plus 2. So my final answer would be 7. My final answer here would be 7. Find them both individually, add them together. The next topic we talked about was tables. So evaluating these tables and being able to fill in these blank spots here. So I have g of x, I have a new g of x. G of x is x plus 4. And if you look here, my input is going to be 13. So on my x row, I have 13. So instead of x, I can put 13 in here. In this spot, we would have 13 plus 4, which would be 17. Kind of the flip of that, if I'm given my output instead, here I'm given 9. Notice that's in my g of x spot, so this time I'm going to plug it in for g of x. And I would say 9 is equal to x plus 4, subtract off 5, subtract off 5, or 4. Whew, man, Mr. Roach. And I'd have 5 is equal to x. And that makes sense, because if I plug in 5 for x up here, that would give me an output of 9, right? 5 plus 4 would be 9 in this case. Last one, I had one more example with plugging in x. So g of -1 for this box down below would be -1 plus 4, and that would be 3. Okay, got 2 more example problems left. Same idea, but now looking at a graph. X-axis is going to be our inputs, and then this y-axis is going to be my output, my f of x. So if I'm asked to evaluate f of 2, that means on your x-axis, on your input axis, look at 2. So here's 2 on my input axis. The graph here, if I'm looking for the graph, is up top here. And my output attached to that looks like it would be 7. 1, 2, 3, 4, 5, 6, 7. So the output associated with 2 would be 7. F of 2 gives me an output of 7. This is a very similar problem to this bottom guy here, where we find both individually. First I would find f of -1. So there's -1 on my inputs. And it looks like the output there is +1. F of -9. -9 is right there. And it looks like my output is here at 1, 2, 3, 4. So f of -1 plus f of -9 would be 1 plus 4, which gives me a final answer of 5. And then the last one down here is find x when f of x is equal to -2. So what input gives me an output of -2? Well, here is my output of -2. And it looks like there are 2 possible inputs for this guy. I'll switch to orange here too. It looks like this input of 1, 2, 3, 4 would give me an output of -2 right here. And it looks like this output of 9 would also give me an input of 9 would give me an output of -2. So you could say x could be 4 and x could be 9. Both would be correct. Both is better than just one, but if you notice just one of them, that would be okay. Okay, last topic we talked about was determining if something is actually a function. Remember, functions, for every input, I need to have one output. So for every x needs to map to a unique y value. If it maps to 2 y values, then that's bad news. So like if you push a button and you get a Coke, you push the same button the next time you get a Fanta, that is a bad function. That is not a function. On a graph, we used the vertical line test to determine this. And if I draw a vertical line through any input, anytime I hit the graph, I should only be hitting it once. So if I draw right here, here's an output right there where you can see it's getting like darker. And if I go up, I have another output right above it. So this input of 3 has an output right here, and it has an output right there, which is bad news. Actually, really lots of different inputs would give you multiple outputs. So we would say, no, this is not a function because it fails the vertical line test. On the test, the actual exam, the summative, I would like to see actual vertical lines. So that shows me you know how to use your vertical line test. And for your explanation, you could just say, this guy fails the vertical line test. As long as you have both, I'll see that you know what you're talking about. The last topic we talked about was domain and range. Domain is the possible x values. And remember, we use this inequality notation, saying that x starts here at -3, and then along my x-axis, it looks like I stop here at 1, 2, 3, 4, 5, 6, about 7.5. So I go from -3 to about 7.5. And this notation is telling your reader that my x's are greater than -3, but less than 7.5. And the only thing that we have to add is, since we touch -3, it could be equal to -3. And since we touch 7.5, it could also be equal to 7.5. It's called inequality notation, showing our readers what possible x values we have. The second part of that is the range, and that's the possible y values. And the nice thing is we use the same exact notation. We go from my smallest y to my largest y. And I'm going to say that this guy actually goes down here just to keep it easy. So it looks like the least that I could be is +2. And then it looks like this guy just about gets to 7 up here. So y is trapped between 2 and 7. And on the test, I'll make sure that they actually go to a number. The only thing to be careful of is these open circles. So if you had a graph that looked like this, we would say its domain, right, its x values, would be -6 to 8. And then we would not put an or equals to sign underneath because of the open circles. Okay, so that's all the review that I have for today. If you need more help or you have more questions, please reach out. These are the main topics on the summative. So if you're feeling pretty comfortable with these questions, if you did them right, I'm thinking that you should be feeling pretty good for the test as well. Have a really good weekend, and I will see you guys next